Welcome. Let's see if we get our YouTube stream going. Looks like it's going. Welcome to another sort of live demo or live stream for Delta Hack, hackathon that we're organizing to just run a couple of days. It'll end at the end of the day tomorrow. So if you've got projects, definitely submit those. The site is on DevPost. You just search for Delta Hack 2021. You'll find the site. You can sign up or submit, whatever projects you have there. But today I've got Christian Williams. I've got Christian Williams, who is one of the primary developers on a daemon in the Delta project called Kafka Delta Ingest. And the goal for Kafka Delta Ingest is to bring data out of Kafka as quickly and efficiently as possible and put that into Delta tables, which can be very useful for data streaming or Spark streaming or any sort of, high throughput stream applications that you might want to be building on top of Delta Lake. Now, Kafka Delta Ingest is still early. It's not quite production ready, but I'm looking forward to learning just how ready it actually is from Christian. And if you've got questions, feel free to throw those in the chat sidebar on YouTube, or if you join the Delta community Slack workspace, which you can find at the bottom of delta.io. You can join us in the Kafka-Delta-Ingest channel on our Delta users Slack workspace. But without further ado, Christian, why don't you go ahead and show us something cool?
Sure. So, like Tyler mentioned, Kafka Delta Ingest is a daemon written in Rust for streaming data from Kafka topics to Delta Lake tables. And we've done a demo on this previously. And so for today's demo, I'm going to pick up on one of the key features. Speaking of that production readiness thing, one of the key features we did not have in our prior demo that we do now have in Kafka Delta Ingest, and that's support for multiple worker processes running for the same topic to table stream, which is of course really useful for handling high volume topics. So I've already got stuff up on my screen, and let me explain what we're seeing here. So prior to running anything here, I set up a Kafka topic with 3 partitions, and the name of that topic happens to be web requests. That's the same example data set that we used in the previous demo, and it's also the same data set that we have in our open source repo that you can run locally. I've launched 2 separate Kafka Delta Ingest workers, and these are each configured
Is that
to
what
write.
We're seeing at the top, and then the second. You've got 4 panes here, right?
Yeah, 4 panes. So okay. The top 2 are my 2 separate Kafka Delta Ingest workers, and they're configured to write a new Delta file every minute. And so in between that time, they're just buffering messages. They're consuming from Kafka, doing some little tiny transformations on those messages, and sticking them in a buffer. So that's worker. Okay, so we got 1 worker in the top, 1 worker in the second pane. The third pane is showing a tail of my Delta log directory. And I've been running this for a while now. And so we have 234 Delta log files in our Delta transaction log. And then the bottom pane is showing how many data files we have in the partition that the example is writing to. So we have 238 files right now. So Kafka has assigned, since we got 2 workers and 3 partitions, Kafka has assigned 2 of these partitions to 1 worker and 1 partition to the other worker. And our output directories, we'll see these new Delta log files and these new Parquet files being written as each worker passes its 1-minute threshold of buffering. Let's peek real quick at some of the outputs that we see here. So I'm using this tool called Parquet Tools to inspect the data in one of the Parquet files. And if we, I think since I zoomed it, it's a little harder to see, but let's see if I can just kind of navigate up here. So one of the things I wanted to,
can you use your mouse to show us what you're looking at?
Well, this should work, right?
Yeah.
So one of the things I wanted to zoom in on to make that point that, we're leveraging Kafka partitions to split the traffic across our workers. And so each of these data files it's going to have each data file will have a mutually exclusive set of partitions. So the worker that is handling partition 0 and 1, all the records are going to have this partition value in our message equal to either 1 or 0, because those are the partitions it's handling. If, however, we look at a different file, so this is a data file written by the other worker that's handling partition 2. So we'll see here, all the records written by that worker were for partition 2. So one other neat thing to inspect. So these are the Delta log files that they don't necessarily correspond to the exact same Parquet files I was showing, but these are Delta log files. And one difference here is that the worker handling partition 0 and 1 is going to include this, we've called it Texan, but the TXN action. It's going to include 2 of those, one for each partition that it's handling, that records the Kafka offset, so that if another worker gets this later, it can look at the version number and then seek to the appropriate Kafka offset. And so that is the worker handling partition 0 and 1. We also have example written by the other worker, only handling the single partition. So next, fun thing we can do now that we're playing with 2 workers. Anybody who's familiar with Kafka probably knows about the concept of a rebalance and the concept of a partition assignment. So if you have the simplest possible scenario and you've got a single topic and a single worker, a single topic partition and a single worker, there's only one place for that partition to go, to the one worker. And there's only one partition that needs to be distributed to anywhere. And so obviously worker 1 is going to handle that partition. If you have a single topic with 3 partitions and only one worker, then still only one worker is going to handle all 3 partitions. When you add another worker to a topic with more than one partition, now Kafka is going to choose which worker each partition goes to. And it does that with a concept called partition assignment. When a consumer joins a consumer group, it's another Kafka concept, Kafka assigns it a specific set of partitions. Now, the number of consumers for a topic can change at any time. And when that happens, something called a rebalance happens. And what Kafka does when there's a rebalance is it basically changes the partition assignment for all the workers. So to demonstrate that, I'm going to kill one of these guys. So I just terminated one of my workers. Oh, yeah. So, and you probably just saw some log messages up here indicating that the other worker,
highlighting,
our partitions were revoked, and then immediately afterwards, we received a new partition assignment. And our new partition assignment includes all 3 partitions because we only had 2 workers, right?
So to make sure I'm understanding this correctly, you terminated, worker number 2, and worker number 1 got all of the workload, basically.
Yeah, exactly.
From worker number 2.
Right. And so once he got his new assignment, he stopped what he was doing, and he went and checked out the latest state of the Delta log. And he found, okay, so the Delta log says the last data we committed to the Delta table corresponded with these 3 partitions, and it had a record written for this. This is what comes out of those Texan actions. It had the offset recorded for each of those partitions. So it extracted those offsets and then did a seek with the Kafka consumer to go pick back up where it left off. So that basically it's only ever when we lose workers, we always start from the last recorded offset, so we know that we're not duplicating data, and we're always picking up where we left off. So eventually, once he hits that 1 minute threshold, he's going to do another write. And let's see, I haven't been watching bottom.
So we patiently watch.
Yeah. And let's
while that goes, could you tell us a little bit about what happened behind the scenes when the second worker terminated? Like what did Kafka Delta Ingest do when that shut down?
That's actually a nice segue. I'm going to switch over to a diagram.
Sounds good. I like diagrams.
Okay.
Sees a diagram.
All right, and I think I'm going to zoom this again. There we go. Yeah, so this is kind of the whole run loop. And just to kind of situate us and be able to answer that question, I'm actually, if you don't mind, I'll walk through it from the beginning. Is that okay?
Go for it.
All right, cool. So when a worker starts up, the first thing that happens is it initializes the Kafka consumer. It says, hey, I'm here. I'm part of this consumer group handling this topic, and give me some work to do. Out of that, it gets a partition assignment from Kafka, which we kind of demonstrated. The next thing it does is it reads the Delta log for the Delta table that it's going to be writing to, and it figures out, okay, for the partitions that I have, these are the offsets I need to start from. So after it reads the Delta log, it gets the offsets out of those Texan actions. And once it discovers exactly what offsets it needs to start from for each of its partitions, it seeks the Kafka consumer. There's API for doing that. So it's like consumer.seek, and you give it the offset for each partition. Then it checks to see, then it starts the actual run loop, and it checks to see, has a rebalance event happened? If it, when we're first starting up, it's unlikely that it has. So it's going to go down this no path, and it's going to consume and buffer the message it just received. And it's going to buffer each message that comes in. Actually got these things out of place. The rebalance happens after consume and buffer. Apologies. So it's consuming and buffering. Each time it consumes and buffers, it checks to see if a rebalance has happened yet. And then afterwards it checks to see, should I write yet? Have I buffered for long enough? Have I buffered either enough messages or buffered for the max time? And if so, it writes out a Parquet file and writes out a Delta log file. Then it goes back to consuming and buffering. In the case where a rebalance does happen, then it rechecks its partition assignment and starts back over reading the Delta log. And just because it's so confusing that I got those things misplaced, and Tyler, you can call me off of this if you want me to just go back to doing something and it's clear enough. But like I mentioned,
I think it's clear.
Okay. This is one of my little OCD behaviors that I just can't, I can't live if this isn't in the right spot. But all right, I'll stop tinkering with it. I think this is enough to get the idea. So basically, we consume and buffer. Have we rebalanced? If we have, we need to go we need to check what our current partition assignment is from Kafka, go back, read the Delta log again, get our offsets, and then reseek and start the whole cycle over. And that is kind of the flow. Does that answer the question that you were posing?
It does.
Okay, excellent. And you're sharing?
There you are again.
Oh, did I drop?
Yeah, a little bit.
Okay. Okay, so I switched back over to
we see it now.
Our console, and let's see here. Oh yeah, okay. So we spent too long on that diagram. We missed the first write, the first exciting write after our rebalance. But as you can see, it picked back up where it left off. Kept writing new Delta log files. So what happens if we restart worker 2? So what we'll see here is we get a rebalance on our worker that was continuing to run, and we also get a rebalance on the new worker. And what's kind of funny
while that first worker was writing, is Kafka Delta Ingest going to write records? Like, is it going to write a transaction regardless of whether it has records every minute, or how does that timer actually work?
No, so basically, if there's nothing in the buffer, it should not write to Delta. Gotcha. Unless we have a bug, which we could. I don't know. But as far as like the designed behavior, for sure, we should, when it checks that should write node in the workflow, one of those conditions should be, do I actually have any messages to write? If not, I'm just going to wait around to actually get some messages. One of the things that's funny that happened here when we terminated that second worker, I think, I could be wrong about this, but I think that second worker was originally handling partition 2 and the first worker was handling partition 0 and 1. And now they're flip-flopped. And that's the thing about rebalance. When you have one consumer handling all partitions and you bring another one on, you don't know how the shuffle is going to come out. It's kind of an interesting nuance that I happened to notice while we were watching this. So let's see. We watched our workers run. We inspected the Parquet file. We took a look at the Delta logs. That's all I had lined up for the demo. Any further questions or anywhere you'd like to go deeper on, Tyler?
Could you share a little bit about the work that's come in lately to make sure that those two workers can actually write to the same Delta table?
Sure, yeah. So originally when we designed Kafka Delta Ingest, we had this concept of a write-ahead log that we were going to use to keep track of the offsets. And let's see here, go back over to our log file. So what we were originally doing is we were only going to have one transaction, one Texan action in the Delta log. And instead of storing Kafka offsets here, we were going to store an identifier that points to a record in our write-ahead log that keeps track of the offsets for all partitions. Somebody on our team had a really brilliant idea. What if we don't do that and instead just write multiple transactions in the Delta log file, multiple Texans in the Delta log file, each would have an app ID specific to the partition and record the offset for that specific partition. So by doing that, we were able to get rid of a bunch of infrastructure that we were going to have to support. So whereas our initial write-ahead log was going to require a DynamoDB table and then a locking table as well, now we're just relying on the Delta log for all of our offset information. And that's what allows us to kind going to maintain this, I hate to use the phrase exactly want semantics, but we think it is. So that's what allows us, that's what allows our workers to pick up where they left off, is relying on these texts and actions in the Delta log.
Interesting. I very much like that we're pushing the Texan notation for how that should be pronounced.
Yeah.
I think that answers all of the questions that I was thinking about. Maybe to wrap us up, if you could talk a little bit about how somebody might be able to get involved, either helping with writing code or testing or documenting or what have you.
Yeah, definitely. And you sent the repository link. Yeah,
I did.
Issues and pull requests are very welcome as far as in any of those three categories: documentation, testing, code. I'll say, a lot of people have expressed interest in supporting other formats other than JSON. And there's even been some talk of abstracting Kafka as the source, so that, this might become Delta Ingest instead of Kafka Delta Ingest, which would also be really cool. Those are two of the bigger items, I think, that would be neat contributions. Some of the kind of smaller scoped things that would be good contributions include like some resiliency to some of the network calls we're doing right now. We've got some pretty limited retry handling in case of network failures when we're like writing to S3, for example. That might be a good easier item to get in on. What was there's something else that just occurred to me. Oh yeah, we're very focused on S3 right now. So if there's any kind of Azure related thing that somebody might want to contribute, really though, that's all at this point. Since we got rid of the write-ahead log, I actually don't think we have any direct S3 or cloud storage touch points. We always go through Delta RS for that. So I might take that back. That's might not be as important anymore. Somebody, I did notice on our issue list, somebody had a really neat issue about. So
I should mention for anybody watching, if you go to the Kafka Delta Ingest repository, good first issues are noted there. So if you're just getting started with Rust or are looking for an easy entry into Kafka Delta Ingest, there's a couple of good first issues that are available.
Oh yeah, here it is. There's one. Somebody had posted this issue to add the ability to access Kafka message headers in transformations. I could see that being a nice, easy add.
Interesting. So Kafka Delta Ingest, I'll reiterate, is open source. It's up on it's part of the Delta project, or Delta Lake project, excuse me. Any parting words, Christian?
No, none that I can think of. Whatever I would say to that would be very awkward, and so I'll just skip. I'll pass. I'll take a pass.
Okay. Well, Christian, thank you very much for demoing the current state of Kafka Delta Ingest. I'm very much looking forward to this finding a production workload soon. I also want to thank QP, Misha, and Neville, who have all been major, I would say, contributors into getting Kafka Delta Ingest this far. If you've got any more questions about Kafka Delta Ingest or want to tinker with it, you can join us in Slack at Kafka Delta Ingest on the Delta users Slack, or hit us up on GitHub, start a discussion, open up an issue, etc., etc., etc. But with that said, have a good rest of your day, and I hope everybody enjoys some Delta hacking. Bye now.
Have a good one, Tyler.